Hello, chemists. My name is Kim. We're continuing talking about alkanes in organic chemistry today, and we're really just going to focus on one thing and one thing only. So last video, we talked about alkanes and how to name simple alkanes that are just in a straight unbranched chain. We talked about how alkanes are carbon and hydrogen compounds or hydrocarbons that contain only single bonds, and we looked specifically at examples where there were no branches, just straight chains in the last video. So when I say no branches, straight chains, I'm comparing that to a situation where there might be branches coming off of one of the carbons. And I'll show you what I mean by branches versus straight chains. If we're starting at the left-hand end of the molecule, at that last left-handmost carbon, I can just move in a straight line all the way down the carbon chain without any trouble. On the branched molecule, on the right-hand side, if I start moving down the carbon chain, I get to a situation where I can go two directions. Either direction has me continuing to go from carbon to carbon. This is a branch. I have more than two carbon atoms coming off of another central carbon atom. It creates bigger and more complex molecules that are a little bit harder to name. So that's what we'll be talking about today. Let's start off with a review of how to name unbranched alkanes. So we've got an alkane below, we've got a bunch of carbons single bonded to each other in a chain and then single bonded to hydrogens. The first thing we need to do is count the number of carbons in the chain. So I count 1, 2, 3, 4, 5. We have to find the prefix on table P that matches that number. So 5 is the prefix pent. And then for alkanes, to make the name, we would add the suffix ane. So this would be pentane. To name branched alkanes, we're going to use the same basic idea, but it's going to get a little more complicated. So these rules can get even more complex. We are going to be dealing with single branched hydrocarbons. So that's alkanes that only have one single branch coming off of them. The first step that we will take, and we will do a couple of examples, is to find what we call the parent chain. This is the longest continuous chain of carbon atoms in the molecule. You may need to think creatively here. Don't always assume that the best thing to do is count from left to right. You are always trying to find the longest continuous chain of carbon atoms, and they may not be in a straight line. You'll see what I mean in some practice problems. The next step is to number the carbon atoms in the parent chain and name the parent chain. When you number the carbon atoms, start at the end that will give the smallest numbers possible to the carbon atom where the branch begins. Next, you're going to identify and name the branch, otherwise known as the substituent. The atoms attached to the parent chain are called substituents. A substituent that is a hydrocarbon is called an alkyl group. The names of alkyl groups use the same prefixes as alkanes, but with a YL suffix. So a 1-carbon alkyl group is a methyl group, a 2-carbon alkyl group is an ethyl group, and so on. The substituents are named by placing the number from the parent carbon chain in front of the name of the substituent. And then finally, you are going to combine the names of the substituent and the parent chain into one word. Again, we're going to do an example in just a moment. There are more rules for branched hydrocarbons that contain more than one branch, but this is all we're going to do for this particular video, is one single branch coming off of the alkane. So let's look at an example together. Our first step is to find the parent chain. This means we want to find the longest continuously running line of carbon atoms. So the easiest and most straightforward thing that you might notice is these 4 carbon atoms that go across in a row. This is a 4-carbon chain here, 1, 2, 3, 4. But there's actually another way I could count this. I could count the 4 carbons like this. There's no rule that says I have to start at the left and go to the right. Now, it just so happens that in this scenario, both ways that I count the parent chain, I end up with 4 carbons in the parent chain. When you are in a situation where no matter how you are counting, you are ending up with the longest consecutive row of carbons is the same number, you can just choose either. So I'm going to just choose, okay, 4 carbons is my parent chain, and I'll choose to use the 4 carbons going across. The next step is to number the carbon atoms in the parent chain. Now there are two ways that I could do this. I could number them left to right, 1, 2, 3, 4, or I could number them right to left, 1, 2, 3, 4. But remember, I want to have the branch, which is that extra carbon down at the bottom, I want to have that coming out of my lowest possible numbered carbon chain. So I'm going to use the numbering system where I started with number 1 at the left and went across to the right, because I want that branched carbon to be on the lowest number possible. Looking at table P, my parent chain would be named butane because there are 4 carbon atoms in that chain, and as an alkane, the parent chain is just a butane chain. We're not done naming this though, because we now need to identify and name our substituent, our branched area. So I'm going to circle the branch. So the branch contains, it looks like 1 carbon off of the second parent carbon atom. Right, here's my branch. If it is 1 carbon, that is going to be a methyl group. Meth prefix from 1, YL, because that's what happens when I have another alkane chain off of an alkane. I call it an alkyl chain. And so then the number 2 comes from the fact that that methyl branch is coming off of my second carbon on my parent chain. Finally, to really finish up the naming for this molecule, I'm going to take the names and put them together. So this would be 2-methylbutane, one word. That name is telling me that I've got a chain of 4 carbons, butane, and off of the second carbon, I have a methyl group, which is 1 carbon and 3 hydrogens. Let's try a practice on your own. I'm going to set the timer here for 30 seconds. I definitely recommend pausing this because you probably are going to need a little bit more time than that. And after 30 seconds, I will go over the answer. To start, we are going to try and identify the parent chain. That means the chain of carbons with the longest consecutive running line. So I'm going to try a couple different possible parent chains. So if I go from left to right, I would have 1, 2, 3, 4 carbons. So that would be a 4 carbon chain. If I go from left to right, but I turn going down, I would have 1, 2, 3, 4, 5 carbons. So I would pick 5 carbons ahead of 4 carbons, right? Because I'm looking for the longest possible chain of carbons. But, and this is tricky, there's actually one other way I could have counted. I could actually start from the right, go over 1, 2, 3, 4, 5, 6. And it turns out that 6 carbon chain is my longest possible chain here. So this is actually a 6 carbon parent chain. Definitely a more challenging way to look at it. So I've got my 6 parent chain here, my 6 carbon parent chain. And I now will want to think about how I'm going to go about naming each of those 6 carbons. I'm just going to get this a little more defined here. I have 2 options for how I can name them, right? Because I have to go either top to bottom or bottom to top. I can start with 1 down here at the bottom and work my way up. So this would be carbon 1, this would be carbon 2, carbon 3, carbon 4, and then sticking with my parent chain here, carbon 5, carbon 6. So that's one way that I can number my carbons. I could also go the other direction. So I'm going to do this in a different color. I could start here and I could say 1, 2, 3, 4, 5, 6. Now, I want to pick the way of numbering that puts the lower number on the branched carbon. So that branch is coming off right here. So what would give this carbon a lower number? Well, my red numbering system gives this carbon a lower number. It gives it a 3 instead of a 4. So I'm going to go with that numbering system. Next, I need to name my parent chain. So I am going to name my parent chain based on the number of carbons there are in the parent chain. So I have 1, 2, 3, 4, 5, 6 in my longest parent chain. That means my parent chain name will be hexane, right? That's not the full name of my compound here, but that is the name of my parent chain, hexane. Next up, I need to identify and name the substituent branch and figure out what number of carbon it's coming off of. So again, just like the last example, this is a 1 carbon branch, but there's only 1 carbon on this branch. So just like last time, this is going to be a methyl group. So the substituent chain is 1 carbon. It is a methyl group, and it's coming off of carbon number 3 this time. We can see that because carbon number 3 right there. So 3-methyl is the name of the substituent chain. So when I go to write the full name of my complete compound here, I'm going to write 3-methyl hexane. One last practice problem. Pause the video for more time. To start, let's find our parent chain. So again, let's count all the possible ways we could do this. I could start over on the right-hand side and count across 1, 2, 3, 4, 5, 6, 7. I could have gone the other direction too, 1, 2, 3, 4, 5, 6, 7. I could also go down. So 1, 2, 3, 4, 5. 5 is less than 7, so that's not going to be it. I could also go around like this, 1, 2, 3, 4, 5, 6, 7. All right, so there's 2 ways that I can count 7 here. I can go straight across, 1, 2, 3, 4, 5, 6, 7, or I can go across and then curve. When you get 2 situations where you are counting the same number of carbons either way, you can just pick whichever one seems to work better for you. I'm going to say it's a little easier for me to think from right to left because that's the way that our writing system works. So I'm going to be looking across like so and thinking about it this way. So now let's think about how I might want to number the carbon atoms in my parent chain. Let's go ahead and just remind ourselves this is where our branch is, and we want to make sure that the carbon atom that the branch is coming off of is numbered as low as possible. So I can see from looking at this, I could number the carbon atoms 1 across like this. I could go 1, 2, 3, 4, 5, 6, 7. Or I can number them 1, 2, 3, 4, 5, 6, 7. And so the blue numbering system is going to give me the carbon with a lower number. So this will be the numbering system that I will want to use. Now I want to name my parent chain. So my parent chain has 7 carbon atoms, and according to my prefix table over here, that makes it heptane. And I want to identify and name my substituent branch. So I'm going to count my atoms over in my substituent branch over here. They're coming out of carbon number 3, and there are 1, 2 carbon atoms in that substituent chain. So I am going to name my substituent chain ethyl, Eth because of 2, YL is the prefix that gets added, and I'm going to put a 3 at the beginning because they are coming out of the ethyl branch. So my answer is going to be 3-ethyl heptane. Let's check back in on our learning goals. Hopefully we feel confident naming an alkane that contains a branched chain. It definitely just takes some practice, and it begins to become more second nature the more of these practice problems that you do, right? It's important to, though, make sure that you can go both from structure to name and from name to structure, these basic single branched alkanes. Good job today.